All right, welcome back, everybody. It's our last class period before the exam on Tuesday. So whatever we finish today, that's what's going to be on the exam, which is, we'll go through the objectives, but it's not all of Chapter 6. It's about half of Chapter 6. So we talked about writing ions, charged ions, figuring out the charges both from the periodic table and from the compound, and then how to write them from names. Today, we're going to go the other direction and talk about how to name compounds, how to name ionic compounds. And then we're also going to add one more thing, which is covalent compounds, so compounds that don't have metals involved and don't have ions involved. How do we name those compounds? All right, so to review from last time, we have these ionic compounds consist of a metal and a non-metal. They come together, and the overall charges have to be balanced. And so we can figure out their formulas from their names by writing down the two ions and balancing them out so that the charges, you have as much positive as you have negative. The other direction now is naming the compounds themselves. So let's look at how to do that. Once you have an ionic compound, you want to name it. So you've got some formula or something like, let's just take one that we know, it's NaCl. So let's say we write down NaCl, we want to know what the name of that compound is. The whole point of doing it this way is so that we know what each other are talking about. We don't have to just memorize giant lists of names. We can figure out the name from the formula, and everybody's going to figure out the exact same name. So if you wanted to look this up, you wouldn't have to know that this is called table salt. You could use these rules and figure out exactly what the proper chemical name of this compound should be. So the first question we ask ourselves is the metal fixed or variable charge? So is there only one possible charge for this metal ion, or is this one of the metal ions that could take multiple possible charges? So what's the answer for sodium or for NaCl here? Is that a fixed charge or a variable charge? In other words, does sodium only ever have one kind of charge, or can it have different values for its charge? It's good that everyone's looking at the periodic table. So what do you learn about? What do you get from the periodic table from that? Fixed or variable? It's fixed. Yeah, it always has the same charge. What's the charge of a sodium ion? Positive, and how many? +1, +2, +3, +4, +1. Yeah, +1. So all the ones in column 1A are always +1. All the ones in column 2A are always +2. That's what we mean by a fixed or variable charge. We drew a little, yeah, we drew a periodic table about that. So all those ones where we always know the charge is the same are called fixed charge, and all the other stuff in the middle is variable charge. All right. So if it's a fixed charge, the name is just going to be the metal ion and then the non-metal with that IDE suffix, I. So in this case, NaCl comes over here, and so we call it sodium from the sodium. And then it's chlorine, but instead of chlorine, we write chloride. The ion form is the IDE. So it's sodium chloride. We don't specify how many of each atom there are in the formula because that can be assumed from the charges. So for instance, if instead of NaCl we had CaCl2, we go through that choice the same way. Fixed or variable charge, calcium's in column 2, so it's fixed charge. So then we just name the metal and the nonmetal with "ide." Calcium chloride. Not dichloride, not calcium 2 chloride, just calcium and then chloride. If it's in that category, that's all you need. The metal name and the nonmetal with "ide." All right, so what happens if we got the other category instead? So let's say we've got Cu2O. Well, now you look up at the periodic table and you see that Cu, which you could look up as copper, is kind of in that middle area. So that goes under variable charge. If it's variable charge, the name looks very, very similar. There's only one difference, which we talked a little bit about on Tuesday. We have to specify the charge of the metal in parentheses and Roman numerals because there could be different possible charges. So we have to have that charge. So it's not enough to call this copper oxide. We have to have a number in there that tells us what's the charge on each copper atom, each copper ion. So we have to figure that out. We can write down first, just because we know so far. In this case, it's going to be copper with something, and then oxide. So the next part is to determine what is the charge on each copper atom. So the way that I think works well to do this is take your formula, Cu2O, and write down all the parts of it. Write down the materials that you're given just as you're given them. So this formula tells us that we have 2 coppers and 1 oxygen. That's what Cu2O means. And then fill in all the charges that you do know. The only charge that we know in this case is oxygen. What's oxide's charge? -2, yeah. So we know oxygen is -2. So then we can say, all right, copper has to have the same charge. All the copper atoms in the compound have to have the same charge. So what does that charge have to be in order for those two things to balance? +1, right. Because if you got -2 overall, and you've got 2 coppers, each of those needs to be +1 to make a +2 overall. So now all the positive and all the negative are in balance. And we can fill in the rest of our name. So we would call this copper 1 oxide because the charge on copper is +1. This is probably one of the biggest mistakes in these things is people want to make that parentheses be the subscript, the number of atoms, and it's not, it's the charge. So when you see Cu2O, you want to call that copper 2 oxide, but it's not, it's copper 1 oxide because it's the charge that counts in there, not the number. The charge, not the number. All right. Let's try that again. Yep. Let's try PBS. So we want to write the name of this one. And our first question is always, does the metal atom have a fixed charge or a variable charge? So what is it for Pb? It's lead. It's variable. It's not in those spots over on the left that have the fixed charge. It's not aluminum, so it's variable. So that means that our name is going to take the form lead something sulfide. Okay, so now let's find the something. We're going to write down the two atoms that are in the formula, one Pb and one S. And then we're going to write the charges that we do know, which is what? Or that we can figure out. Sulfide. What's the charge on sulfide? Yep, -2, just like oxygen. Remember, anything in that column is going to have the same number of valence electrons, so it's going to have the same charge. So our sulfur is -2. So then what does the lead have to be to balance that out so that it's neutral overall? +2, yeah. So that +2 is what goes in the parentheses here. We put a Roman numeral 2 there. We call this lead 2 sulfide. All right, so that's sort of how it works. We're going to keep doing it. I mean, it's not sort of how it works. That is how it works. We're going to keep doing it. We need to look at one more class of ions. So one class of ions that we haven't talked about yet. New page here. And that is, they're called the polyatomic ions. So far, all of our compounds have been made of one kind of metal ion and one kind of nonmetal ion. Those are known as monoatomic ions. There's just one atom each. There's another class of ions called polyatomic ions where you have more than one. And I'm going to show you how to identify those first. So the compound that has a polyatomic ion in it might look something like this. NaNO3. If we were to name this with our rules, it wouldn't quite work. Because remember that the charges always need to balance. And we know sodium's always +1. We know oxygen's always -2. Nitrogen's -3. So there's no way that balances. So what's going on here is we don't have individual ions of sodium, nitrogen, and oxygen. We have an ion of sodium and an ion of this whole other part. So this whole thing stays together. This is just one ion. And what would the charge on that whole ion be? Any idea? If that has to all stay together as a whole ion, what would its charge be? I'll give you a hint. NaNO3 has to be neutral. So what does the charge on NO3 have to be to balance with Na? Yeah, -1, because we know Na is going to be +1. So this whole ion is an NO3 ion, and it's called nitrate. So it has a different name. The naming rules and everything we just did all stay the same. This doesn't change any of that. So that compound, we'd still look at the sodium first, say it's a fixed charge, but now we have a different ion to pair with it. So we call this compound sodium nitrate. Sodium nitrate. All right, the bad news with these ions is there's no clever way to figure out what their formula or their name or their charge is. So you can't look at the periodic table and find N and O and figure out what a nitrate ion is going to be. You just have to know them. So we have a list. It's on the objectives on Blackboard. There's 7 of them that you need to know for this class. We're going to go through them now. So for each of these, you need to know the name, formula, and the charge. Because we can't figure out the charge from the periodic table, so we just have to know it. All right, here they are. We'll start with the one we just did, nitrate. Nitrate's formula is NO3, and its charge is -1. Then we've got sulfate. And you've probably heard these words before. These are all very common ions. They're important in the body. They're important in the environment and other kinds of things. We've got sulfate, which is SO4 with a 2- charge. There's phosphate, PO4 with a 3- charge. Okay. Carbonate, which is CO3 with a 2- charge. Bicarbonate, which is HCO3 with a -1 charge. And just 2 more. Hydroxide, OH or sometimes HO with a -1 charge. And finally, ammonium, which is the only positively charged one that we're going to learn, which is NH4 with a +1 charge. All right. So you'll notice, except for ammonium, they all have oxygen involved. So if you see a formula where you've got more than one nonmetal and one of them's oxygen, you can be pretty sure that you've got one of these ions that we're dealing with. Another common source of problems with these is that a few of them sound really similar to some monoatomic ions we've already talked about. Nitrate, for instance, is NO3-, but nitride, IDE, is N with a 3-. That's just N by itself. Same thing with sulfate, and then we've got sulfide, also phosphate and phosphide. So those are very similar, but they're totally different ions. So remember, the way to remember that is that the IDE suffix, the ide, goes with the monoatomic ones, which is 1 atom, like the ones from the periodic table. And whenever you see 8, that's talking about the ones with the oxygen. It's like they ate more and they got bigger. There's more there. All right, let's try these. So we're going to do the same thing we just did. Come up with some names of some compounds, write some formulas based on some names, but we're going to incorporate these in there as well. Let's try these two to start with. So we've got two compounds. First, we're going to ask, are they ionic, and which kinds of ions are they? So let's start with the first one, K3PO4. So is there a metal there? Yes. What is the metal? K, which is, you could look up, it's potassium. And so is that going to be a fixed charge or variable charge? Fixed, in that same column with sodium, right. All right, so that tells us that our name is just potassium phosphate. We don't have to do anything else. Once we figure out that the metal ion is fixed, we just put the two names next to each other and we're done. So this is potassium phosphate. All right. Now that went a little quick. We figured out that the metal ion was fixed, and so that tells us we don't need any parentheses. But there's another decision to make here too, which is what is the name of that anion? What is the name of the negatively charged ion? And this is why you have to commit this list to memory, because we have to know that when we see PO4, that's called phosphate. Okay. All right, let's try the next one. So the next one has a weird kind of thing going on where there's these parentheses around the SO4 and then a 3. Why is that done that way? Why isn't it just CO2S3O12 or something like that? Why group those in that way? Any ideas? Is it helpful to have a group like that? It really is, because it really points out that the ion, the anion, is this SO4. It's not S and O separately. It's SO4 together. So again, that polyatomic ion. All right, so the metal ion here, where does that go? Is that fixed or variable? One charge or multiple charges? Multiple charges, right? It's variable because it's right in the middle there. So that means that this name is going to be something like Cobalt something, and then we name the anion, which is Sulfate. Okay, so we have to figure out that charge. We do it the same way as we did it before. We just have a different ion to deal with. So we write out all the things that are expressed in the formula. So in the formula, we've got a CO and another CO, because it's CO2. And then we have 3 sulfates. SO4, SO4, SO4. Each sulfate is -2. Again, there's no way of figuring that out. You just have to know that the sulfate ion has a charge of -2. The only way you can get that. So for now, we look at our list on the left, but next week, you'll just have it in your head. And then we fill it in. What does each cobalt have to be charged to balance out the 2- sulfates? What? Yeah, so we need 6 plus total, which means each cobalt has to be +3. Because we have -6 overall. So each cobalt is +3. Now we have +6, -6. It's a balanced formula. So that +3 goes right in here. 1, 2, 3. So this is what we would call this cobalt 3 sulfate. All right, let's go the other way. So I'll write a couple names. You try to write the formulas. All right, ammonium chloride and copper 2 nitrate. So we're going to do it just like before. You're going to write the ions down and then figure out how many of each you need to make a balanced formula. When you think you got something, show the person next to you or around you and see if you agree.
So you read the 3, and then you put the parentheses 2. Just like the example above. Right. All right, get a chance to look at these. Anybody have something? Little? All right, we'll go through them together. We'll see how it goes. All right, so the first one, ammonium chloride. We're always going to start by writing down the ions, writing down just directly what is said here. Now, ammonium is not an element, so we can't just look it up on the periodic table. So what do we write down for that? Yeah, NH4 plus. That's one of the ones from our list. And what about chloride? Chloride is a Cl. And what's the charge on that? -1. Yeah. Yep. Not quite. Chlorine refers to the neutral atom. Chloride means the ion, the negatively charged ion. It's Cl, yes, same symbol, Cl.
That's fine.
Yeah. All right, so we've got NH4 plus and Cl minus. How do we put those together so that the charges balance out? Do we have to adjust how many of either one that we have? They just match, right? +1, -1, they go together. So our formula for ammonium chloride is NH4Cl. That's it. Okay, let's look at the next one. Same thing. We're going to write down what we've got and see how they go together. So here we've got copper 2, which we look up as Cu. That's 2 plus because it tells us in the name. Copper 2 means it's 2 plus. And the other half, nitrate, again, not a single element, but a polyatomic ion. So we write that down also, and that's NO3 -1. Get that one from the list. The list right here. So how do we put these two together so that the charges balance? Yeah, so we've got 2 plus on the copper side, but only 1 minus on the nitrate side. So in order to bring those into balance, we need 2 of the nitrates so that we have 2 plus and 2 minus. So that means the overall formula is going to be Cu, and then the way we make 2 of those whole nitrate ions is by using parentheses.
and say we have two of those whole things together. All right, good. Let's try some more. So I'm going to list some formulas and some names. Write the names for the formulas or the formulas from the names. Grab a book here, make sure I've got reasonable stuff here. First one, write a formula for aluminum sulfate. Then we're going to write a name for NaHCO3. Na3P. Cobalt 3 phosphate. SNF2. You don't have to do them in order either. If there's some that jump out at you as being a little quicker or easier, try those first. What? Yeah, I just want to give everybody some time to keep a track. All right, looks like some good tries out there. Don't worry if you didn't finish them all, or this takes obviously a lot of practice and a lot of thinking about to get it. But I want to look at some of these, and then we've got one more piece to add to it before we're done. So aluminum sulfate, we're gonna write those pieces down. Aluminum, sulfate, and then the way that we can balance them into a formula is to add their charges. So aluminum's +3, sulfate's -2. Aluminum's charge we can figure out from the periodic table because it's in column 3. It's the only one in column 3 that's 3+, but it's always 3+, so 3 valence electrons. Sulfate, the only way we can know that charge is by looking it up in that table, well, which we'll know eventually. So then we have to bring those two into charge balance, which means we need 2 aluminums and 3 sulfates. And so that final formula will be Al2SO4 3. 2 aluminums, 3 sulfates, so that we have 6+ and 6- overall. All right, the next one's a naming one. We look at the metal. It's sodium. That's a fixed charge. So that means we can just write the 2 ions. We also have to know the name of the second thing because we recognize that there's a whole bunch of atoms there. That makes it a polyatomic ion. So what's the name of HCO3? Anybody remember from the list? That's bicarbonate. So this is sodium bicarbonate. That's baking soda. Aluminum sulfate, by the way, is also a household thing that's an antiperspirant. All right, next one, Na3P. Same thing, we look at the metal first. It's sodium, so again, we don't need those parentheses. And then what's that ion's name? What's the anion's name? The other ion here. I know what's P if it's just by itself. It is, so what is the ion? So what would we call the ion? Yeah, phosphide. And when it comes to the exam on Tuesday, the important thing is following the naming rules. So like, if you knew that it was phosphorus and you knew you had to drop the end and put on "ide," but instead of phosphide you wrote phosphoride, I would say that's fine. I mean, it's not technically the right name, but you used the rules properly and you like came up with a thing that makes sense. So you don't have to know every little nuance of this. I just want to know, can you follow these main rules that we've been talking about? I would mark it wrong if you wrote sodium phosphate, because phosphate is a totally different ion. That's PO4. All right. Like in this next one, cobalt 3 phosphate. So going from the name to the formula, we're going to write down our ions. Cobalt 3 is cobalt 3+. Phosphate is PO4 3-. So that works out. 3+, 3-. We don't need to change anything there. So it's just COPO4. And then finally, SNF2. So we start in the same place. We look at the metal. It's in the middle part, so it's variable charge. We look that metal's name up. It's tin. So we know we're going to need some parentheses here. And what's the anion called here? Fluoride, yeah. So now we got to figure out what the charge on tin is so we know what to put in the parentheses. We can write down the pieces here, SN and F and F. So one SN, two Fs. We know F is always -1. So that means tin has to be +2 to balance that out. So this is going to be tin 2 fluoride. This is some stuff you could get prescribed by your dentist if you really need some heavy-duty fluoride treatment. They'll give you some tin fluoride. They call it stannous fluoride, I think, which is kind of the old-fashioned name. The reason we do the naming rules like this is because before these rules, you just had to know the name of everything, and they were all different. So you had to know that SNF2 was, or SN was stannous stuff, and you had to know that NaCl was called salt and not sodium chloride, and you had to know that KNO3 was saltpeter, and there's all these different ones. You just had to know all those names. So this way, it seems difficult maybe to find these names and these formulas, but it's standardized. You can even type these things into a computer, and the computer will know exactly what formula you're talking about because it can figure it out based on the rules. So that's why we do this. Okay. We're going to put one more piece in there. That is the molecular or covalent compounds. We're not going to get into what covalent compounds mean or what molecular compounds are until next Thursday, but we should be able to name them in with everything else. So these are compounds, and how you identify them, first of all, is no ions, which means no metals or ammonium, because that's not really a metal, but it's an ion. So these are compounds that don't have any metals in them. And that's going to be your clue as to when to use these rules instead of the others for naming. If you don't see the metal, if you don't see ammonium, now you're in this new class of compounds called molecular compounds. So these are things, some of which you already know, I'm sure, like CO2. CO2 is made of carbon and oxygen. There's no metal there. Does anybody know the name of that molecule? Yeah, carbon dioxide. And the major idea of molecular compound naming is there is no predictable way that these things go together. In other words, with the ionic compounds, if you had sodium and you had chloride, you can figure out their charges, and there's only one possible compound they can make. But with molecular compounds, there's lots of different ones. Like, does anybody know another compound made from carbon and oxygen? Yeah, carbon monoxide, CO. Let's add that one to the list. So it's not enough to just say the two words. We have to be more specific about how many of each atom there are. And the way we do that is with these prefixes. So let's make a list of those prefixes. If there's one of something, we say mono. If there's two, we say di. If there's three, we say tri. If there's four, we say tetra. Penta is 5. And hexa is 6. So we say exactly how many of each atom there is in the name. Let's try another one. So N2O.
N2O is a common molecule, so it's often known by its common name. Does anybody know what the common name of this is? What? Yeah, nitrous oxide. But if we want to name it as a proper molecule using these rules, we want to specify how many nitrogens and how many oxygens there are in this name. So we use these prefixes and we say dinitrogen monoxide. You'll notice it really should be monooxide, but whenever there's like two O's together, an A and an O, we usually cut off that extra vowel. If you leave it in on an exam or something, that's fine. I'm not going to mark it wrong. So if you said monooxide instead of monoxide, that's okay. But we usually cut off one of those vowels and just call it monoxide. So you see how we said how many of each atom are there right in the name? The other thing that you might notice here, if you look back up at the carbon dioxide and carbon monoxide, is if there is just one of the first atom we don't say mono. Because there's most molecular compounds are going to start with just one of an atom. So if it was mono everything, it would be confusing, and you want to look it up or something in a book, the M section would be enormous. So we just say carbon dioxide, we don't say monocarbon dioxide or monocarbon monoxide. And really the easiest way to remember these rules, I think, is to think about those compounds that you know, like carbon dioxide and carbon monoxide, and think about what's happening in those names, and then apply them to whatever new ones there might be. So let's try one. How would you name SF4? Yep. Very good. Yep. Sulfur tetrafluoride. So we recognize that there's no metal there, so we're not doing any of the stuff that we did before. We just say exactly how many of each thing there are, and we leave the mono off of the first one. So this would be sulfur tetrafluoride. All right, what about P2O5? Do we have a name for this one? Yeah, diphosphorus pentoxide. Or if you said pentaoxide, that's okay too. Yeah. With an O. Are there any other ones that start with vowels? I'm trying to think. Iodine still is the same. You don't drop anything with that one. I think it's just with oxygen. Yeah. All right. So actually the hardest part about naming these types of compounds is that this way of naming is so nice that it makes you want to name everything else this way too. And that's the source of a lot of errors that I see, is after you kind of get this naming system down for molecular compounds, you want to go back and call this tin difluoride. That's not really the right name for that because it's an ionic compound. So this is all the new material now, and now we got to put it all together. There's a few different ways you can keep this straight. The book, I think, has a nice flow chart, which I'll copy into the notes so you have it also if you don't have a book. Oops. All right, so if you go into chapter 6, it is just after the naming stuff. There's a bunch of guide to problem solving with naming compounds. And there's this flow chart. Not the best designed flow chart, but the content is good. So let's put it here. I realize it might be a little small for you to read from where you're sitting. What page is this? This is on page 187. But what you're going to do first is something that we haven't done yet, because we just learned the molecular compounds. The first thing is to decide whether this is ionic or covalent, because they have different ways of naming. And the key for that is to look for a metal. Okay. Ammonium, that positive polyatomic ion, also can be a problem there, but mainly you want to look for a metal. So if you see that it's molecular, then you do what we just did. You use your prefixes. If you see that it's ionic, then you have to make decisions about what those things are. So this was the main decision that we were focusing on today. Is it a fixed or variable charge when you name it? Does it need the parentheses or not? If it does, you just say the name. If it doesn't need the parentheses, you say the name. If it does need the parentheses, you say the name followed by the charge that you're going to have to figure out. And then on the nonmetal side, you either have a monoatomic ion, where you just say the name of whatever it is with ide, sulfide, phosphide, oxide, chloride, bromide, whatever. Or you have the polyatomic ion, where you say the name of the polyatomic ion. And that's it. So really, I think the hardest part of doing this is when you don't see it in context of a category, and you have to figure out where it goes and what kind of rules you need to use for naming it. So let's try that. I'll give you a mix of a few of them, and you've got to figure out which rules to use and then what the name is. All right. So here's 4 more. Take a few minutes, and before you actually write the name,
I want you to write what category is it in. And here's your 4 choices for categories. So 1, it's molecular. 2, wait, 3 choices for categories, sorry. 1, it's molecular. 2, ionic with a fixed charge. 3, ionic with a variable charge. So make a little note of category 1, 2, or 3 before you start naming it to remind yourself to use the right rules. And flip back in your notes if you need to refresh the rules and how you're going to do that.
Just has to figure it out. Where is it?
All right, I'm sorry if you're done with those, but we're getting low on time, so I want to go through these and tell you about some other help for this stuff. So let's categorize these first. The first one, which category does that fit in? Molecular, ionic with a fixed charge, or ionic with a variable charge? Ionic fixed, yeah, number 2. And what about ClF5? That's going to be molecular, no metals in there. CCl4, same thing, molecular, no metals in there. And then Cu3N. Right, that's going to be our variable charge because the copper is in the middle. If you can separate those in those categories, that's like half the thing right there. Then, because if you know the rules and you know which category it goes in, now we know which rules to use to name these things. So for the first one, we know that's in number 2, so we're going to use the number 2 rules. The number 2 rules say just put the 2 ions next to each other with their names and nothing else to do really. So we would just say magnesium nitride. And that's it. Nothing else to do with that one. All right, molecular, the next one. So since we categorize it as molecular, we know that we have to specify exactly how many of each element there is. So we would call this one chlorine pentafluoride. 1 chlorine, 5 fluorides. Next one, again, molecular. So we're going to specify how many of each thing there is. So we've got 1 carbon and 4 chlorines, and we call that carbon tetrachloride. Okay. And then the last one, Cu3N. Now this one's going to take a little more work because it's in category 3. So we know that we need to name the 2 ions, but then also have this parentheses. So we've got copper something nitride. And we need to figure out the charge on copper so we can put it in the parentheses. So we list the atoms that are in the formula. 3 coppers, copper, 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 and 1 nitrogen. We look up at the periodic table. Nitrogen has 5 valence electrons, so it wants to gain 3 more to get to 8. So that's a 3 minus or minus 3 charge. And then what does each copper have to balance that out? +1, yeah. So plus, plus, plus. And that tells us that a 1 goes in the parentheses because it's copper 1 nitride. They need a copper with a +1 charge. All right. So with our last 5 minutes, I want to show you some resources to help you prepare for the exam on Tuesday. So first of all, I know a lot of you know this, but all of the notes and the videos from class are online. Notes are right here. So all the things that we've been doing with their dates are here. I just added on to the Tuesdays because it was the same topic. But you can see even the stuff that I just wrote is already on there. Nope, it's not. What's going on here? Okay, we'll have to do that at the end of the class then because it didn't quite work. But all the notes from previous are on there. So you can look at all those. The videos from our class are a couple links down right here. So if you want to go revisit some of those things, they're right there. We've got our chapter objectives here. So we've gone through measurements, energy and matter, atoms and elements. And then the ionic and molecular compounds, we've gone through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's see, 11, 12, We haven't done 13, 14, 15, 16, 17. So that's all molecular stuff. How to draw molecules, electron dots, so don't worry about that. We have talked about the naming of molecular compounds, so that's good. And then we haven't done the rest of this stuff, electronegativity, polarity, attractive forces. We haven't done that yet, so that'll be next week. So you can review those things in there. Additionally, in the notes folder, I've put a couple more documents of some practice problems. Chapter 2, because I know people wanted a little more practice with that. That was the conversions and density, all that stuff. So there's, I think, 80-some pages of problems that I printed off from an online homework thing here. The answers are also there, so you can check that. And then there's also one for Chapter 6 for the naming stuff. So you can look at that as well.
Where did you post it? It's in class notes?
They're all in the notes. Yep, they're in the notes folder. All right, so that'll be some, yeah, here's the naming one here. So that'll be some good practice as well. All right, this one doesn't have quite as much, only 40 pages. So yeah, maybe don't print them out, but you can look at the question and then try to answer them if you want to save some paper. Okay, in addition to that, my other class is the Monday, Wednesday evening class. On Monday evening, we're not going to be doing new material because it's exam week. Their exam's on Wednesday. So if you want to come by, it's just going to be questions and review and going over whatever people want to work on. That's Monday, 5:30 to 8:15. I don't know if that works with your schedule, but if you can make it, that's what we'll be doing. The beginning of the class, we're doing the quiz because they didn't take the quiz that we took on Tuesday. Or was it Tuesday? Yeah, Tuesday. They didn't take that quiz because they're off a little bit because of Labor Day. But anyway, so you don't have to come right at the beginning, but somewhere around 6 something, we'll start and just going through and reviewing and getting ready for the exam. So if you want more in-class time to work on stuff, to ask questions, come to that. That'll be just the day before the exam, so you should be pretty much ready by then, but if you need a little bit extra. And then exam day itself, remember that the exam is technically scheduled for the lab period, but we have class beforehand. So that time beforehand, we can use however you want. If you don't want to talk about the exam anymore, you just want to do it, we could do that. If people have some questions, some last minute things you want to go over, we could do that, and then maybe take a little break and then start the exam when we start it. So plan on being here at 12:30, and we'll start whenever everybody's pretty much ready to start. So send me messages through the Remind app or through email this weekend if you have other questions. You can send pictures of stuff that you're working on if you're not sure why you're getting something wrong. Yeah, whatever you need, we'll try to get you ready for this first exam. So happy studying.
It's all ICT or written?
Mix. There's old exams on Blackboard, so it'll be the same format, same kind of format, like half multiple choice, half other stuff. Yeah.